Hello guys again. So recently I just got my hands on this pure sine wave inverter, and I think it's a pretty good product. It's the Go Power 1000 watt model GP-ISW1000-12. So it's a 12 volt inverter, 12 volt to 120. And I kind of like it because I had really bad luck with inverters, and I already tested this one, and so far so good. So I really couldn't find much information about this on YouTube or anywhere. So I would just like to go over the functions on this and how it works and what it does, and then maybe do some testing on the voltage and the sine wave. So let's start with the front panel. There is not much on the back panel. There is just the DC connection, and since I'm talking about it, it will take actually pretty good size of the cable. It will take this hook eyes in the back, and I already have it connected to the battery, so I don't want to turn it around. But this is pretty much what I have there, and it's a number 1 copper cable. It doesn't really require this size. This is an overkill. This is from my 3000 watt inverter, but the cable, the best cable that you can find, it's in a welding supply store. Okay, this is the very fine wire for low volts, high amps. Okay, and the more strengths you have, I don't even have cut one. I did. Hold on a minute. I didn't get a cut wire here. Yeah, this one is not number 1. This is a little bit smaller. I don't know what size is this, but it doesn't matter. But the number of strengths. Okay, let me get this a little bit closer. The finer these strengths are, the better it's for use with low voltage. Because I don't want to get into it. It's just pretty much just take my word for it. Okay, this one is number 2 actually, and that would be more than enough for 1000 watt inverter. I'm just saying, all of these cables are from welding supply, and they've been used for stick welders. If the cables go bad, they will just, this is just a replacement for the cables, and those machines, they use very high amperage and pretty low voltage. So these are like the really best cables for the inverters, for the DC side, from battery to the inverters, or even connecting the batteries in parallel or series. Okay, so that's just about the back side pretty much, and I think you can easily use number 2 for this type of inverter, maybe even less. For 100 amps, probably number 2 would be good. But anyway, and these hook eyes, they are actually, I actually solder these connections. That's the best thing you can do. Don't even bother crimping these things. Just push it in and solder it. Just have the solder, just tilt it this way and have the solder, fill this with the solder pretty much. Okay, when you're soldering these. That's the best connection you can do for your solar system. But let's go back to this puppy here. Okay, well, let's power it up. I'm gonna zoom a little bit so we get to the front panel, and maybe center it a little bit too. Okay, that's pretty good. Now you can see we have a 20 amp GFI outlet. Pretty much this is how you reset it. Okay, this is a tripped one, and it will trip whenever it will detect ground fault. But this outlet will work only when you use the ground on this machine, okay, if you're not going to use the ground for outlet is useless pretty much. And I would not even put it on the inverter at all, but anyway, it's there. I really don't care. If it goes bad, I will replace it. That doesn't bother me at all. And so the other functions, this is off, this is to switch it to the remote, okay. I don't have the remote. It's about $90. I don't know if I ever gonna get it. I really don't see the use now. Would be nice, but probably, maybe, I don't know. But this is the remote control, and the remote control has actually a little bit more functions than just whatever you can see here. Actually more, not really more functions, but more visual, like measurements of the battery and the voltage coming out and stuff like that. Okay, so this is off, and this will be just to turn it on. Now this is kind of important. This is the hookup to the remote. That's the power cable for the remote, and I believe there is another one. Yeah, there's the same thing on the back of the unit. Okay, so we're not gonna get into that. It's not exactly important, but for example, let me see. I'm gonna have to get a magnifying glass because I'm blind, kind of. So these slides here. Okay, so the first one will show you when the battery is low. Orange it's low, and red is like critical low. The middle one is the sine wave, which I really don't understand what it's for. I guess when it's green it's a pure sine wave, but that I don't want to get into it. I don't know. And this is an overload pretty much. And if you're gonna load it up to the up to 1000 watts, well, we can actually test it. That's not a problem either. But it will turn red, and it will go into the overload for maybe a second or two, and then it will shut off. Okay. We will get into it, but we can get back to this when I put some load on it. But let's get into these little switches here, and this little dimmer, or whatever you want to call this thing, potentiometer. Okay, now these switches is your voltage pretty much. These first three switches is your voltage. It will go from 110 to 115 to 120, and that's fairly easy to figure this out. Okay, when you get a voltmeter over here. The last one, it's a power saver, and that one I really couldn't understand from anything until I got this unit. And the power saver is actually a really nice feature. This unit will take about 1 amp consumption power. Just eat up 1 amp by itself from your battery. If it's running or if it's not running, if it's just standing still. Okay, when it's turned on. When it's turned on, it will eat up around 1 amp. And I can test it, but you know, it's in the specs, so I don't have to prove myself here. But this feature here, if you turn it, oh, I'm sorry, I forgot to mention one of these switches is also switched to 50 Hertz and 60 Hertz, which is useless for America. Okay, when you're gonna switch to 50, I don't know, never. So it's 120 volts. I don't know why would they even bother with that. But anyway, let's go back to this last switch here. So this switch here will put it into power save mode. Okay, and the way it works, that's kind of important. Right now it's off, so the power is coming out. Let me get something to plug it in. Let's get a hair dryer maybe. Okay. let me actually unzoom a little bit here now. So I'm gonna plug the hairdryer in, and right now it's on all the time. Okay, now you're gonna turn on this switch here. After a while, it's gonna go into power safe mode, just by itself. It's gonna take some time, and maybe I'm gonna have to adjust this dimmer here. I will call that dimmer because I cannot pronounce the potentiometer. Okay, so let's call it dimmer. Let me get a screwdriver here, and I don't know how is it right now. This is probably, yeah, this is a little bit too big. Yeah, I'm gonna get a small one. This might be okay. Ah, I'm sorry, my mistake. You have to shut it off. And let's go back a little bit higher settings here, and then turn it on. I mean, you should shut it off whenever you change these switches here, because otherwise it will not do any good. It has to be, the unit pretty much has to be restarted. Okay, now it went to the sleep mode. Excuse me, cheers. So now the power is off, and the unit is only blinking. Whenever it blinks, it will draw a little power, and this is just pretty much to keep it alive. Okay, I'm sorry, I'm blocking the view here. Now this is how it works. This dimmer here, it will pretty much adjust, or you can adjust how much load you have to put on this unit to turn it back on. Okay, so if you go all the way to the left, when you turn it this way, it will be the least load, or maybe it will even turn on completely by itself. You can try that. Let's go all the way to the left, and it will be on. Okay, so pretty much whenever I turn on the hairdryer right now, let's actually unzoom a little more. Okay, the power is on. Okay, now just because this is all the way to the minimum settings, now we're gonna set it on a little bit like on a little load, and I have to wait for it to go to sleep. Okay, so I hope I turn it enough, it will go to sleep, and I can actually shut this so you can see the lights better. And maybe I didn't turn it enough, but it will take some time before it goes to sleep, so we'll see. I think I'm going to have to turn it a little more, because that is not exactly... Okay, now it's off, so let's put it like right in the middle somewhere. Okay, I just don't want to fuss with it too much right now. But this dimmer here, this is the adjustment, how much load you have to put on the unit to make it work again. And this is the way it works. Okay, I'm going to turn on the hairdryer, but it's in very low settings right now. It's going to be only 100 watts right now. Okay, so I might need a little more, but let's try 100 first, and let's see what happens. It will go on, and with a little delay it will turn it on. Okay, that's pretty much how it works. Now if I'm gonna turn this all the way to the right, well, all the way is going to be a lot of load. So anyway, just, you know, don't want to waste your time. But if I'm going to turn it all the way to the right, which is the maximum load, I'm going to turn the hand dryer on, which is 100 watts. It will not even wake up the unit. Okay. And as you can see, we just getting a little kick when the light goes on. But it's not actually turning on. So I'm going to go to 170 watts. Let's see if that's going to turn it on. Probably not. Okay, that's still not enough. So I'm going to go to 500 watts. Let's try that. And it's still not enough. Okay, so I'm going to go to let me see. I have to read this because I don't remember that. This is 500. So I can go to 800 watts. Okay. So let's go to 800 watts. And still not enough. That's kind of disappointing, to be honest with you, because 800 watts is almost the maximum load. So I don't know what it's going to take to turn it on. I mean, you can try 900. Okay. And as you can see, 900 watts will draw a lot of power over the battery because I have only one battery connected to it, and that will turn the battery voltage will drop so much that this will become orange. But it's not in a critical position. It's just a little bit lower voltage of the battery. Okay, but this is what's killing me. This is a kind of a useless feature here. Okay. I don't know whoever is gonna want to adjust the power and turning this on or turning this off. I think if this could be just set to 100 watts maybe or something like that, and you know, pretty much like right now it's set. I don't know what is it set to, but if I'm gonna give it 170 watts. It will wake up. Okay. So this is a fairly useless potentiometer here. I would rather see another switch or potentiometer and adjusting the battery voltage, the battery cutoff voltage, than this nonsense. But other than this nonsense, this is a pretty good unit. Okay, I'm going to switch it back to the normal, if I can get the right screwdriver here. So, of course, I have to shut it off. I mean, I should shut it off when I switch these things, but I keep forgetting. And I'm going to turn it on, and now it's on constantly. Okay, so I'm going to hook up some meters to this, and I'm going to get into the sine wave and the voltage drop and everything. Okay? Okay, so now I got the oscilloscope and the voltmeter hooked up to it, and my beer, of course. I'm a little bit thirsty, so excuse me. So the sine wave right now, there is no load on it. It looks really good. It's not as good as the Honda 2000i or 2200i inverter generator, but you know, for an inverter I guess it's pretty good without a load. So I'm gonna put 600 watts load on it, and it's just a heater. There's no fan. It's just a heater itself. Okay, 600 watts. You can hear the fan kick it in, and the voltage stays fairly good. Sine wave is fairly good, and lights are still green, so that's not a problem. And I have it switched to 120 volts, by the way. Okay, so that's good. So let's go to 900, and I hope the battery will last, because I just have a temporary hookup to the battery here. Okay, I'm going to switch it to 900 volts. It's exactly about 920. So you can see the sine wave is getting a little bit crooked here, and I don't like that, but the battery, this is just a battery, is getting a low voltage on the battery, but the voltage stays pretty good, and that's about 900 watt load. And I can add another 100. Well, yeah, right here. Let's see if we're gonna trip it. This is exactly 100, and still holding. And another setting is 140. So this is already over 1000 watts, and still holding pretty well. Doesn't go into overload. Okay, voltage is good. Very small voltage drop, only 2 volts. I'm gonna shut it off. I don't want to torture it too much. So that's good. Okay, the sine wave is not as good when we go a little bit higher voltage. I mean higher wattage draw. So, well, you know, I'm not going to use it for that purpose. I'm going to use it for a refrigerator and a couple, and maybe few LED lights. And I did start the refrigerator on this, which has no problem. Full size kitchen refrigerator. Okay, no problem whatsoever. Not even turning on the lights. And I'm not gonna go into it, but what I want to get into it right now, and I didn't try, it's to start a furnace. It's a gas furnace, the whole house gas furnace. And I'm gonna hook up the furnace, and I'm gonna keep these meters attached, and the furnace will have a really big draw at the beginning, probably about 2000 watts. Maybe even more. I don't know exactly, but I would have to probably get a clamp meter and see what it's going to draw. But it's a whole house furnace pretty much. It's a gas whole house furnace, so it's going to have some draw at the beginning. So I wonder myself if this is going to take it. I believe this might be a little bit too much for it, but we'll see. I will get back to you when I'm ready. Okay guys, so this is the temporary hookup. This is the plug on the furnace that I have extension cord coming to it. Okay, all the way to the inverter here. Let me get it situated again. Maybe right here would be good. And I have to admit that I was wrong on the ground, because as soon as I connect this to the furnace, it tripped the GFI here. So as long as you're using 3-prong plug here and you have the equipment connected to it, grounded through this cord, then it will trip the GFI. So I don't want to get into that right now, okay? But I had to disconnect the neutral into the main electrical panel and flip the breaker, obviously, so it doesn't trip the GFI. But now I'm gonna go and turn on the furnace, and it's actually my first time to try this thing. Let's see what's gonna happen. Okay, and the furnace just kicked in, and we have still pretty good voltage, so I guess this has no problem to turn on the furnace. Let's see what kind of power draw we have here. About 48 amps roughly, which is not too bad. I don't know the starting draw. I'm kind of I can still get to it. Let's see. Let's leave this to the maximum. I'm going to shut it off. It's going to take a while before it shuts off. Okay, actually it just shut off, so let's see. Max, minimum, and let's see what kind of draw we're going to get here on the startup. .78 amps on a low DC side, so that's not so bad. I was expecting a little more. Here it is. Okay, 78 amps on a DC side. You can do your math yourself, I'm sure. And then on a normal draw, oops, let's switch it, let's zero it, 47 amps. It's drawing from the battery on the DC side. So you can do your math, I'm sure. So pretty much 47 times 12, roughly. It's 470, that's about 550 watts. That's what it takes. Okay, well, that was pretty good actually, and I'm pleasantly surprised that I could run furnace on this thing. I'm gonna go shut it off again. Okay. And I think that's it. That's pretty much all it is. Like I said, I'm not going to test the AC right now because it's a kind of a winter time. But if it runs the furnace and if it runs the refrigerator, maybe I get to the AC later. But I'm not going to use it for AC. That's the thing. I don't need it for AC. The AC takes a lot of power, and that's going to just eat up the power out of the battery. Okay. If I'm going to AC, I'm going to run the generator. So cheers, guys, and I hope you learned something. I did.